So what you're seeing right there is the result of a single slit diffraction experiment. You clearly can see that the central maxima is the brightest and the largest of all the bright fringes. So I'm going to try to zoom onto it, okay? So we can see that the quality is not the best. I'm really trying just to capture the essential here. I'm going to proceed just as I did with the double slit. I'm going to take a piece of paper, map out what I'm seeing on the board onto my piece of paper, and then I can use an equipment, a measuring equipment, to find now what the distance y is. All right, so take a look. Bear with me, it's not the best, it's definitely not the best, but got to get this working, got to give you something to work on with your lab. So I'm going to capture this, then I'll see you around when we do after we've mapped out and we have the dimensions. All right, okay. So guys, this is kind of the result we got after mapping out the single slit experiment. Again, this is not the best of results. I'm running out of time, and I really wanted to cover this part with you. So basically what I want you to see clearly, my central maxima is the biggest of fringes, right? And the two other ones are almost half that size. So in order to measure my y for the single slit experiment, I'm going to take 3 fringes, not just one, but 3 fringes. I'm going to use my vernier caliper again. All right. A vernier caliper gives me something of about, hold on. It gives me something of about 11.7. Well, I'm looking at the sliding scale to find an approximation. Let me see. 0 is a little bit offset, 1 is offset, 2 is offset, 3, 4, 5, 6 is offset, 7 is, 8 is, 9.6 seems to be my, 9.6 seems to be my best bet. So 11,796 centimeters. All right, 11,796 centimeter is the length of how many bright fringes? 1y, 2y plus 2y's of 4y's. All right, so 4y's, which is y, and 2y in length. Because it's a single slit experiment, the 4y's are worth a distance of approximately 11.796 centimeters. You can use this to solve for the distance for the length y. All right. You know you're dealing with a green laser this time, so you know what the green laser is. If you look that up, you can find the wavelength of a green laser. And as for the length from the light source to the screen, I'm going to provide that in the PowerPoint slide. So using that length of the light source to the screen, using the value of y, and using the wavelength of your light source, which is a green laser, you can solve for W or A, which is the width of the aperture in the single slit experiment. So I'm going to measure that length L, and I will provide that in your PowerPoint slides. I hope this helps you understand the phenomenon of interference and diffraction and how to solve for the different size of the apertures, depending if you're dealing with a single slit, double slit, or a diffraction gradient, okay? Again, thank you guys for bearing with us during this period, and most importantly, when it's all said and done, I hope you guys stay safe, and I hope to see you around, at least if not for the subsequent classes, see you around in good health, okay? So go ahead, take this data, and proceed with your lab reports. All right, thank you.